Hello guys, this is Dr. Jan Knows Chemistry and welcome to my platform. If you're writing chemistry practical on Wednesday, I'm talking about chemistry practical alternative A 2026, you better sit down and let's go together from the beginning to the end of this video, because in this video I'm going to be breaking down what you should expect in 2026 chemistry practical. All right, so please make sure you get your writing materials and let's start jotting what I have to say, because in this video you're going to see a lot of things. Make sure you take note of them. All right, the first thing I want to talk about is the titration. I want to believe that you know the titration procedures now. This is not the time you're just learning. You ought to have started since year 10, 11, 12, and you should be perfect at titrating now. And if you need me to actually remind you, what you do during titration, you set up the apparatus. The main thing is Burette. All right, that is where you're going to feed the acid, which is going to be labeled A. Then you have a conical flask. That is where you're going to use the pipette to transfer 25 cm³ of the base into the pipette. Then you put your indicator. In this case, WAEC, they use methyl orange as indicator most of the time, but in this particular year, please maybe you should inform your teachers as well if it's possible. We don't know exactly which indicator they will use in this titration. They may use methyl orange and they may use phenolphthalein. You have to practice with those, the two, not just one. You may see on Wednesday and then they just say the question, they say use methyl orange as indicator. And if you have not used phenolphthalein before, they can just tell you use the phenolphthalein as your indicator, because you must record the indicator used at the top of your table for titration. So what about if you have not practiced the titration that involves phenolphthalein? Because the end color is not the same thing when you are carrying the titration. So most of you are used to methyl orange. So that is why it's important for you to practice the two. All right. So after that, you run the acid into the base, you shake it, and then you get to the end point where the color will change, permanent change. Then you record it. That is your title value for that particular titration. And I believe that you remember that very well. So in this titration, we're going to be using our acid, which is just H2SO4, and the next one is the base, which is NaOH. All right. Luckily for you, WAEC, they usually write the equation for you, but because this is just a simple titration that involves the acid and base, you should be able to write this on your own. What about the first question after titration says, write a balanced chemical equation for this reaction? All right, so you may need to write it like this. H2SO4, this is an acid, react with a base, all right, to form salt and water. Don't just leave it like this, you have to balance it, because it is this balancing chemical equation that you're going to get the stoichiometry of reaction, and that is the mole ratio of the acid to the base. So because I have Na2 here, I put 2 there, so I have 4 H2 like that. So it's balanced. You can see that this is 1:2. So they can tell you to balance it. Write it on your own and balance it. But most of the time, I think they wouldn't want you to make mistake from this start. They will write it for you. But I can tell you, if I have to set the question for you, I can tell you this is a very simple question. Every year 12 or SS3 students should be able to write this. What about if they don't write it for you? You better do that. Sometimes they may use H2SO4 again, look at that, and put X to represent Na, and put XOH. Whenever you see something like that, whenever you see Na, just put X there. So this is X to SO4 plus 2H2. It's the same thing. Can you see that? I just put 2 here. So I'm just saying that we never can tell what they can do for that day. So they can as well put H2X here. Look at that, H2X. They've used the whole of SO4 to represent this. So we now have NaOH. So of course, this is going to be Na2X again. Can you see that? Because the whole of SO4 plus what? Plus 2H2. So it's still the same thing. So anyhow they write these equations, still the same thing. It's this 1:2. But I'm just telling you, as good news, they are likely going to write it for you. But it's important for you to master it now. So no matter how they change it on that day, just understand that I've told you that it's very simple and you can deal with it. So this is just the writing of the equation that is used in this titration. And this is the list of what we do. The first thing they will ask you to do is to carry out the titration. All right, they will tell you to carry out the titration. And what you need to do, last year in 2025, they give space for you to draw your table. Some years, sometimes they draw the table for you to fill it in. All right, but last year, 2025, they didn't draw any table. They just tell you that to prepare your table. So you must learn how to prepare your table very well. But before I go into this main thing, I want to tell you the reason why you must take your chemistry practical very seriously. All right, number one is usually titration, and that is what we are dealing with. Number two is qualitative analysis. All right, number three is like theory to practical. So practical related, let me just write the practical related questions. Okay, let me just put it like that. Look at this titration. Before, let's just say 20, 20, 10. That is 50 marks. All right, this is just the usual distribution. I've seen some years that they will put this one as 21 and this was 19 and 10. But do you know what they did last year? Last year, I don't know, this is like above 26, but what I'm just telling you, like, this is just 5. This is 5. So this O2 is like 45. Can you imagine? And because you can practice these two right before your examination. You practice the titration that that is likely to come out. You brainstorm on what question can they ask us on this qualitative analysis. This third one, we can't predict it, but it's going to be practical related question. It could be titration, it could be question on titration, it could be on separation techniques, it could be on tests for gases, those complementary tests for gases. What is the test for hydrogen, for chlorine, for sulfur oxide, and stuff like that. But look at this, you have these 45 that you can actually prepare for and know this is likely going to go. So I'm going to be providing you some insight about this whole of 45 marks in case they repeat the same thing and make this number 3 question to be 5 marks, which you can't predict, but we can as well predict the whole of this thing. So I'm expecting every one of you, after watching this video, to score nothing less than 48, 47, or even 50-50. All right, so if you have done that, just understand that your score with just little push will get to B3, B2, or even A1. So it's very important for you to listen very well so that we can go on with this titration. Now, when most students find titration very difficult, it's not even the titration itself, because they've been doing it for a number of years, up to 3 years. And if I prepare students, I want to prepare students from year 10. I start from 2nd or 3rd term, year 10, that is SS1, to start teaching them how to titrate. So that means by now, I believe that you're perfect at it. But most people make serious error in drawing up the table. So let me tell you how to draw the table, because when you're writing the exam, it's also most likely that I'm going to leave the space for you to draw up your table. The first thing you need to do here is Burette reading. Okay, I hope you have seen that. Burette reading. Okay, then put the unit here. All right, so look at that. Just want to do that for you. So after that, you must write rough. I can put rough titre, I can put rough titration, but you have to be consistent. So this is rough. After this, you can say first titre. Can you see that? That is the rough. Then this is the second one, second titre. You can write it in word too. Second titre, all right? Then you can make it third titre. All right, so let me just remind my table. You can see how it is. So the first thing you do after that is write final Burette reading. Okay. You can also put CMQ here in brackets, just like I've done here. All right. So, but don't do it with the figures. And the next one is initial Burette reading. Okay. I can still put CMQ here. All right. So what is going to be the next thing? You can see how I'm building it. That means, so this is volume of acid used. Volume of acid used. Okay. So that means after the titration, this is the volume that you used. Okay. I'm just looking at this. Okay. So let's just manage this. Let's manage this table like this. Okay. So it's okay that way. Some of you may be like, oh, how they will not. If you like, you can put CMQ here. I'm talking about CMQ here again. Okay. So, but never here when you are writing the stuff. So when you fill your Burette to 0, so that shows that initial you're starting with 0.00. Make sure it is to 2 decimal places. All right, just like you say something is 10.2. Don't write 10.2, but so it must be in 2 decimal places. Please write that one. It's very important. 0.00. I hope you have seen that. Now, the first titration I did, after I filled my acid to the burette and I transferred my 25% cube to the conical flask. All right, I hope you're following what I'm saying. This is my conical flask. All right, after I've transferred the 25, I put the methyl orange indicator. Then I started titration by releasing the acid and shake it properly to make sure that the reaction. Some of you will just open the tap and you don't even shake it. The shaking is not just for fun. It's for the proper mixing of the reactant to make sure that the acid you're releasing is mixing and reacting well with all the base that is there. All right. So as you are releasing the acid from the burette, it's picking up all the bases, okay, turning it to salt like that until there is no more base. So the last drop of the acid will change the color, and that's what I got 12.60. Can you see that? 12.60. So that is it. Now I top it back to 0. Okay. So the next one I did, I got 12.30. I've actually done that. Okay. So this one, let's say you top it back to 0. That means I got 12.10. Then top it back to 0. I got 12.20. Okay, these are the values that I got. All right, now listen. When you see 000 like this, I'll just smile at that student. There is nothing, they won't remove your mark, but it shows that you don't even have any skills about titration. All right, if the color change at 12.6, remember your burette that you are using has 50 cm cube capacity. Okay, so if total value is like 12, that means it can take another 12 to make it 24. So you don't have to keep topping it to 0. So, but if this is what you want to do, it's beautiful. Nobody's going to deduct any mark for topping it to 0 as long as you have the acid to top with. So you keep doing that. Now, let's assume I don't want to top it to 0. All right, so I'm just telling you this. From here, I top it to 0. Let's subtract it, 12.60. Then this one, 12.30. All right, so if I continue, look at this. I continue from here. So this one will be my 12.30. That's what it means. This one will be my 12.30. That means I continue from this. That means first rough titre, I ran it, I got 12.6. I top it to 0. Then the color changed at 12.30. I don't have to top it to 0 again. I start from there. So now the color will change around when you add these two together, because I want to get 12.1. So when you add this together, you get 24.40. That's what it is. So the color will change 24.40. So when you remove it, you got this. All right. So this, let me explain this first one and second one. I carry out the titration first, and the color change at 12.60. Now I top it to 0. That's why the initial, what I'm starting with, that is the initial burette reading. Burette is this. All right. So after that, you get 12.30. Now I didn't want to top it to 0 again, so I just throw away my solution, rinse my conical flask, and pipette another 25% cube in conical flask, put it indicator, then I continue. So this one that ended it was starting the second one. Then the color will change like this. Let's assume I top it to 0 back, so I got 12.20. All right, so this is a very beautiful titration. Some of you may not know the reason why it's beautiful. The reason is very, very simple. The reason why this is beautiful is just like I have what we call concordant values. All right, please, I want you to write it down. It is very important that you get what the values that are concordant. Okay, concordant. What does that mean? It means when you carry out your titration, different subsequent titrations, the gap between them should not be more than this. You can see that 12.3, 12.1. That is 0.1, 0.2. This one and this one. This is rough. Rough, you may not need to use it, but there is no rule that says you should not use it. If you know how to titrate, but the rough, I always tell my students to just let it guide them. Let me tell you why rough titration is very important. As a student, I must listen very well. The reason why rough titration is very important is because when you want to start titrating, you don't know where the color will change, and you don't know exactly where you should be so careful in dropping your acid, just drop by drop. Now, if I'm carrying out titration for the first time, all I do, I just run the acid and I keep shaking. Where the color will change, color change at 12.6. Now I feed it back to 0. Do you know when I want to start titrating again? I know that the color will not change before 10. That's what it means. So when I'm running it before 10, I may not even pay attention. But once it gets to around that 10, I start dropping, drop by drop, because titration is very sensitive. You know why I say it's a very sensitive technique now. Very, very sensitive. And you must get something very great. Now, once you start running after you got to 10, you go to 11, drop by drop. You know, there will be the last drop that will change the color permanently. And that is why it is important for you to know where your rough is. So the rough will guide you where the color is like going to change. So you pay attention around that time. So once you do it, you do this and do that. Some of you, after getting your titration, some will get 12.8 here. Now you got 12.1 here. You get 13.2 here. So, and 16.12 here. Look at this. This is a rubbish kind of titration, because of the fact that there is nothing you can use here, because they are not concordant, they are not close. So you must have at least 2 that will be very close. The 3 can be as well close. Once you have them, then that is what you're going to use to calculate your averaging, and that is your titre value that you use for your calculation. So we are titrating many times to make sure that we have accurate results. Look at this: 12.3, 12.1, 12.2. And I said concordant values must be this close. All right. Now look at this. Which of them are concordant? Let's take this drop out of it. The first titration, second and third one. So which of them? The 3 are concordant values, because the gap between them is no more than this. So the first thing that WAEC will ask me to do is to calculate the average volume of A used. Okay, of acid used. What you do in this regard is to now pick the first, the second, and the third. Do you understand that? So you say first, second, plus the third one, divided by 3. Remember, because this, and this, they are concordant. The gap between them is within this. So let's say I got this one to be 12. Let's say 4. This is 12.1, 12.2. I'll use this one plus this divided by 2. So please don't make any mistake about this. So let's add it together. 12.30 plus 12.10 plus 12.20 divided by 3. All right, so it's like taking this. So everything is given 12.20 cm3. All right, so this is your VA. That's the average volume of acid used. That's the volume of the acid that will completely neutralize the 25 cm³ of the base. So at the top of your table, you write the volume of B used. That is your volume of pipette. So in this case, we use 25 cm³. That's what I use for this titration. All right. So then indicator. This is just to guide us when we're marking. It doesn't actually have mark, but it's important for you to note it so that we know exactly what you're doing. So indicator use, let's say, is methyl orange. Remember, I've told you, you have to practice with both methyl orange and phenolphthalein, because WAEC may decide you're using phenolphthalein for that calculation. Let me talk on that. You are used to methyl orange, that when you put the methyl orange in base, it's going to be yellow. All right. I'm going to show you some video about that. So it's going to be yellow. As you're adding acid, it's picking up the base. Then when the colors become something like permanent orange, then you stop. But that's not the case when you use phenolphthalein. The color of phenolphthalein in the base is like pink, very bright pink. All right, something that looks even purple. So it's like pink. So, and in acid, it's colorless. So, but you add this, so you are starting with pink solution. So some people will just put phenolphthalein and they say, oh sir, look at the color of my, because you're not used to it. So in case WAEC decides that you're using phenolphthalein, make sure you write phenolphthalein as an indicator, and that's what you're going to do. So you're starting from, so when you drop the acid will react with some base. Let's say we have 5 molecules of base, I'm just telling you. So one drop of acid will cancel this. All right, remember, pink solution of phenolphthalein is inside this. So another drop of acid will cancel this. Another drop of acid will cancel this. Another drop of acid will cancel this. All right. So at this particular point, there is a particular color, but you will not know it has actually ended. So the last drop of the acid you just turn everything to colorless because the color of phenolphthalein in this. So it's like you are titrating to colorless. That colorless means that you have dropped extra one particular drop of acid to turn it to colorless. So you have to do this titration as well using phenolphthalein, not just meteorite, so that you can carry it. So if you use phenolphthalein, you're likely going to get a lower titer value, maybe around 11.8. I think I got 11.8, 11.6, thereabout. So our titer value now is now 12.2. Let me now tell you why your titration will have to be accurate. How do you think WAEC will score this for you? And I want to tell you right away. Let me just use this. Now, on that day that you are carrying out the titration, WAEC will also give your teacher another form. Please go to one corner, or maybe you do it before the student will start theirs. What did you get as your titer value? So because WAEC understands that everybody is not going to get this for one reason. I've mentioned it. It can be the integrity of your chemicals. That means how good your chemicals are. Maybe a faulty apparatus, the technical know-how on how to calculate how to set up and do the normal titration. So it can affect that, but it should not be far from what the titer value should be, because sometimes when you are doing your calculation, if it involves something you have to subtract another point from another, if your titer value is too far away, they can have a serious negative there, and that would eat up your scores. Okay, so let's look at what I'm talking about now. After your teacher must have done his own titration, usually before you start yours or even while you're doing it, your teacher will get a titer value. Let's say it's 12.2 like I've got here, or like this is actually the titration that I did myself. All right, let's say 12.2. Now if your titer value is like 0.15 close to your teacher, you get the whole 4 marks. All right, that is it. We assign you 4 marks. Okay, so if it's like 0.20, you can see it's getting away. You are getting 3 marks. Let me put marks here so that you can know it's marks. Okay, so can you see if your own is now 0.3 away, you are getting 2 marks. If it is 0.40 away, you are getting 4 marks. If it's now 0.50, 0, everything here is 0. Can you see that? So, and look at this 0.15. It's not something that is big. Or look at this. If I add this one to this, it can be below. It's plus or minus. This is plus or minus, okay? So, let me just add this one to this. So, 12 point. If I add 15 to this, that makes it 35. Okay, look at this. 12.20, 12.3. But I can see it's not much. Let me add just 0.2 to it. It becomes 2.4, 12.40. I've already lost 1 mark for every titer because I'm going to score not just one of them. Look at that. 12.040. It's 12.20. Almost the same thing. All right. They just changed this one some 2 years ago, I think. Before it starts from 0.20, you get 4 marks. But now if it's 0.20 away from what you have already lost this mark, you are getting this. Can you see that? And that's the reason why you have to be accurate. Why you have to be accurate. I don't encourage my fellow teachers to tell the student what the titer value will look like. The best thing you need to do, if your teacher is using the same solution that you're using on that day, you should get the same thing. All you need to do, transfer, measure accurately. That's what. Make sure your pipette is good, is not broken, so that the volume will change. The burette is not leaking. All right. Use the required drops of the indicator. As your teacher told you, use 2 drops. Fine. All right. So when you do the titration, I'm telling you, you are likely going to get the same thing. Look at what I got. All right. So you can see 12.1, 12 point is just like that. So it's important for you to know that you have to understand that. So please learn to perform the actual titer value. And this is what you're going to use for the calculations. I hope you understand that. That's what you're going to use for the calculation. So let's quickly see some of the questions that are predicted. This is just one of them. I've predicted about 13 different ways why I could ask you a question on Wednesday. All right. So, and I'm going to share it. Just drop your email. I'm going to drop a link. You click and get to our WhatsApp platform so you can have access to that and make sure you don't miss it. See different ways that WAEC can ask you questions. You have today, tomorrow, before Wednesday to make sure that you practice this, and that will be beautiful. So let's quickly check how we're going to use this. Now I'm going to clean this table because what we really need from this table is to get our marks because the titer value are well done. Then we are only interested in the 12.20 calculation of our what? Of the titre value. I'm talking about that's what we volume of acid. That's what we want to use for these calculations. Okay, so look at the questions right on your screen. So let's quickly watch how we're going to do this, and it's very, very simple. Remember, I've told you that I've predicted just about 15 questions, different ways why I can ask you the question. So it's important for you to practice them, because any one of them can just come out. You can come back to this platform to see that, oh, this is actually what came out. So the volume of acid used, remember, is that of H2SO4, which is labeled A, is 12.20 cm3. All right. So the first question there says, calculate the concentration of A in mole per dm³. Calculate the concentration of A in mole per dm³. Remember, we can calculate concentration of acid in mole per dm³ by using concentration in gram per dm³ over molar mass. But in this case, we don't have the concentration in gram per dm³ of the acid. All right, what is given is impure, so we don't use that. And whenever you can't use that formula, you just use CAVA over CBVB equals the number of mole of acid over number of mole of base. All right, let's write our equation again. H2SO4 plus NaOH. I hope you have seen that. We give you Na2SO4 plus H2O. So balance it, so we have 1:2. So that is it. So NB is set to 1/2. Then concentration of acid in mole per dm³. That is what we are told to do. So I write it like this. Then volume of A, that is your titre value. All right, don't forget that. That is what you did when you are carrying out the titration, and that is what you're actually looking for. So we have 12.20. All right. Concentration of B is given as what? 0.100. Remember, that is in the question. Then what's the volume of B? All right, that is the volume of pipette used, which is 25. If in your center you use 20, this would be 20. All right, so this is 25. Now it gives you 1/2. How did I get that? 1 mole of acid to 2. I did that from balancing. Can you see that? From balancing. So that's why your equation must be balanced before you carry out this calculation. Most of the time they will write it for you, but in case they don't write it, I've told you it's a simple stuff. And let's make CA the subject of formula. CA equals 0.100 times 25 times 1. Can you see that? Over 12.20 times 2. So what is that? We're going to put it in 3 significant figures. I didn't say 3 decimal places. It could mean something different. So 0.1, let's do that. 0.1 times 25. Okay, we're dividing it by 12.2 and dividing it by 2. Okay, so 0.102 mole per dm³. That is the concentration of acid used. And you can see that that is very simple, isn't it? Concentration of acid used is 0.102 mole per dm³. Now, what's the next question? The next question says calculate the what? The mass of pure H2SO4 in 1 dm³. Look at that. Mass of pure H2SO4 in 1 dm³, mass gram 1 dm³. So that is gram per dm³. So we're going to use this formula for the second one. Concentration in mole per dm³ equals concentration in gram per dm³ over molar mass. It's that simple. Concentration in mole per dm³ equals concentration in gram per dm³ over molar mass. So what's the molar mass of H2SO4? Let's calculate that. H2SO4. So H will be given to you as 1, so 2 times 1, plus S is 32, plus 4. Oxygen is 16. So that is 2 plus 32 plus 4 times 16 is 64. By the time you add everything, it's 98. What's the unit? Gram per mole. All right? So that is what we're using for this calculation. Now, put that into this calculation. What is the concentration in mole per dm³ of the acid used? That is what we got, 0.102. Because the concentration in gram per dm³, is that what they said we should do? That is concentration in gram per dm³. Over molar mass is what? 98. So concentration in gram per dm³ will now be 0.102 times 98. So whatever you get, that is the mass in. Okay, that is that. So let's quickly multiply that. 98. Okay, so 10.0. Okay, 10.0 gram per dm³. So if they say what's the mass of pure H2SO4, that is 10 grams in 1 dm³. That is what we said, 10 grams in 1 dm³. All right, so that is very simple. The next thing is percentage purity. Let's quickly do that. Percentage purity. What is percentage purity of this? Remember, percentage purity is pure over impure times 100%. This is the quantity of the acid that reacted with the base. So that is the pure. All right. Look at the impure. Impure is given already. Impure is given as 12.14 gram per dm³. From the question, can you see? So percentage purity. All right. Percentage purity will now be pure over impure times 100%. It's that simple. What is the pure? That is 10.0 over impure. Impure is what? 12.14 times 100%. So whatever you get there, that's the answer. Let's quickly put that. 10 divided by 12.14. Okay, so times 100. So we get 83.4%. So 83.4%. That means solution A is what? 83.4% pure. All right, 83.4% pure. So let's say the fourth question, which is the last one, and that will end the calculation in this titration. Remember, after this, we still have some other ones that we have predicted. There will be like other 12 that you need to practice before the day. This is just one of the ways in which they can ask the question. So let's quickly go into that fourth, which you're going to finish in a few minutes. All right, the fourth one is calculate the volume of solution A that will neutralize 0.075 mole of sodium. Okay, the volume of this acid that will neutralize what? 0.0075 mole of NaOH. All right, so remember that the 20 what is the volume of the acid used? 12.20 cm³ of acid. It neutralized what? 25 cm³ of 0.100 mole per dm³ NaOH. Can you see that? 12 point, that is the color change at this point at 12.5. So that means this volume of the acid neutralized this quantity of base. So let's just calculate the number of mole here, right? So what is the number of mole here? N equals to CV. Okay, so that makes it what? C is 0.1 times 25 1000. Can you see that? So that is CV. Remember, volume is in cm³. Divide it by 1000 to make it to convert it to dm³. So C is condition in mole per dm³. Volume must be in dm³ as well, so that I can get the mole. All right. So 0.1 mole per dm³ times 75. So this is like 0.1 times this is 0.025. All right. That is 0.025. I'm going to divide this one by 1000. I get 25 back. So by the time you do that, we're going to get 0.0025 mole. All right, what it means is just like 12.20 cm³ of the acid will neutralize 0.0025 mole of base. So what's the volume that will neutralize 0.0075 mole? All right, so just cross multiply. You get X will be equal to 12.20 times 0.0075 over what? Over what? Over 0.0025. So when you look at that, this is just like 3 of it. So we get 12.20 times 3, which is 0.663 cm³. So we will need 36.60 cm³ of this acid to neutralize a solution that contains 0.0075 mole of the base, and that is going to be your answer. All right, so I want to believe that you learned a lot of things from this. Don't forget, make sure you click on the link that will lead us to our WhatsApp channel. That is where you're going to see or have access to other questions that were predicted concerning this titration. So see you in my next video.